Okay, welcome everyone to our study of the define function. The define function is one of the more unique functions in FindBI, and it can help solve many challenges related to indicator calculations. In this course, we will primarily cover the basics of the define function, how to write this function and how to use it. In the second part, we will discuss the differences between define, define_add, and define_sub. In the third part, we will explore another function called the earlier function. In most scenarios, the earlier function is used together with define, and combining these two functions can create new solutions for more complex scenarios. This combination is especially helpful in practical applications. Of course, while the define function is powerful and can calculate a wide range of indicators, it does come with a learning curve. Therefore, this course is primarily intended for data analysts and IT professionals. However, if your work involves a lot of analysis and your analysis complexity is high, or if you have some difficult indicator calculation challenges, you are also welcome to learn from this define course. Once you've mastered it, it will certainly help in your practical work. Before we start the formal lessons on the define function, I'd like to ask everyone a question. Do you know what aggregation calculation is? For example, I have an Excel table. In contrast to aggregation calculation, we also have row-by-row calculation, or detail calculation. For example, when calculating gross profit, we do this calculation row by row horizontally, which is called row calculation. On the other hand, aggregation calculation is done vertically. For example, if I want to calculate the total sales for all regions, I would sum up the sales in each row. Aggregation calculation is something familiar to many users who have worked extensively with Excel. A classic example of this is a pivot table, which is a perfect representation of aggregation calculation. For example, if I summarize sales by year and month, this is an aggregation calculation. When data moves from detailed data to aggregation, we see a decrease in the amount of data. This process helps us answer questions. For instance, looking at a detail order sheet with hundreds of thousands of rows, I may not be able to answer how the overall sales performance is. But if I aggregate the data by months, I can see the sales trend for each month, which helps answer questions about sales performance. In everyday life, there are many aggregation calculations as well. For example, what is the average math score of my classmates? How much money did my family spend on groceries this month? What is the total sales of the company in the Shanghai region this year? We can see that answering these questions requires performing aggregation calculations. Here, I define three key elements for aggregation calculation. First, there must be dimensions or granularity. What level of granularity is used for this aggregation? For example, math corresponds to the subject, this month corresponds to the time, and granularity could be by month. Second, the indicator. This refers to the specific indicator for aggregation, such as score, money, or sales. Then, the aggregation method. We've mainly discussed summing, but aggregation can also include average, max, etc. Once you're familiar with these, let's take a look at the define function. The define function is used for calculating indicators at a specified level of detail, or granularity. You can think of this granularity as a dimension, such as province or year-month. Here's the standard syntax for the define function, according to its official documentation. It consists of three parameters separated by commas. First, the aggregation method and indicators. This corresponds to elements 2 and 3 in the aggregation calculation. It specifies which indicator to aggregate and how to aggregate it. Second, the dimension or granularity. This indicates the level at which to perform the aggregation, like province or year-month. Finally, the filter condition. This is optional and can be left out in some cases. We will cover this later. Let's look at an example. The first example is define some AGG sales province. This means we're aggregating the sales by province. For example, if the province Jiangsu has 3 rows, we sum up the sales for these rows. 100 plus 200 plus 100 is equal to 400. The result of this aggregation will be output in every row, which may lead to data inflation if not handled properly. The second example is define average AGG sales city. This means we're calculating the average sales by city. For example, if the city Suzhou has 2 rows with sales of 100 and 200, the average is 150. Through these examples, you should now understand the basic structure and usage of the define function. Let's return to some practical examples. For instance, if I want to know how much money my family spent on groceries this month, the metric is money, and the aggregation method is sum. The dimension is this month. Similarly, if I want to know the total sales in Shanghai for this year, the metric is sales, and the aggregation method is sum, while the dimension is year and Shanghai region. So, what are the advantages of using define? You might wonder, isn't the same effect achieved in my group table? When I drag a dimension and place the indicators, isn't it just a summary calculation based on the dimension I dragged in? Hasn't FindBI already implemented this for me? So, why do I still need to use define? The real advantage of define lies in its flexibility. It allows you to specify things freely. It doesn't restrict you based on the framework in your view. But what does that really mean? Let's take a look at an example in FindBI. Now, let's take a look at this example in the FindBI project. For instance, right now, I'm performing an aggregation calculation on sales by the district and store name, right? At this point, we notice that expanding the data works fine. We can see the sales for each store. However, if I have a new requirement where I want to add a column that shows the total sales for the district each store belongs to, what should I do? We will find that if I simply drag the sales figure in, it won't work. This is because it's defaulting to aggregation based on the 2 dimensions I've dragged in, district and store name. In other words, the granularity is too detailed for my needs. At this point, we can use the define function. Let's look at how we would write this. To see the total sales for each district, the indicator we're aggregating is the sales figure, and the aggregation method is sum to get the total. The dimension we're interested in is the district, so the dimension would be the district field. Once we've written that out, let's drag it into the table and check it. Let's adjust the data format. When the data is collapsed, we see that the results are the same for both cases. This is expected because when we collapse by store name, the sales aggregation is based on the region field, and the results are correct. Now, let's look at the expanded view. Here, we see the difference. Without using the define function, when I drag the sales figure directly, it aggregates by the store name dimension, so we see the total sales for each store in the district. But when we use define, since the dimension we specified is district, even in the expanded view, we still see the total sales for the Southeast district, not broken down by each store. This shows how the define function allows us to control the granularity of the aggregation and ensures we get the desired results. Let's go back to the PPT. At this point, everyone might have a sense of the difference between using define and directly dragging indicators into the analysis. Of course, the example we've used here is just to help everyone feel it out. This is just the tip of the iceberg of what define function can do. Now, let's continue. We've skipped over a section called filtering conditions, which is our third parameter. Let's take a look. I have a question. How do we calculate the total sales for each province after 2021? Let's break it down step by step, following the method we just used. What's the indicator? It's sales, right? How do we aggregate it? We want the total, so that's sum, right? So, sum AGG sales, that's the first part. What's the dimension? It's the province, so that's the field for our dimension. But I have a special condition. I only want the data from after 2021. So, how do we handle this special condition? As you probably learned in FindBI, there are many ways to do this. For example, you could add a filter condition in the component or in the data to filter. But what if I don't want to filter the underlying data but only filter for this specific calculation? The reason is that I might want to use data from before 2021 in other components, and if I filter the underlying data as mentioned, it would affect those components too, right? This is where we can use the third parameter, the filter condition. The syntax for the filter condition is year greater than or equal to 2021. This filters out data where the order date is after 2021. Of course, this third parameter can do much more, such as working with functions like earlier, which we mentioned at the beginning. This function can be used here in combination with define to perform dynamic filtering and cross-row calculations. We'll go deeper into this in the third session, but for now, let's just understand the purpose of the third parameter. So, we've discussed a lot of theory and knowledge. Now, let's do a hands-on practice to reinforce our understanding. Here's an example of conversion rate analysis. You can find the data in the PPT, or you can directly search for the keyword define in the help documentation. The example is also included there. Let's take a look at the required result. This is a detailed table of customer numbers at each stage in a car sales process. We're going to find BI to check it out. Now, I need to calculate the number of customers at each node and, based on these nodes, calculate a conversion rate. Let's keep it simple for now. We'll calculate the conversion rate based on the first node. So, the desired result is like this. For the delivery node, the conversion rate is 107 divides 39,521. For the order node, it's 1,111 divides 39,521. Now, you can think about how we would implement it with define function. To analyze the conversion rate, we need the customer count at each node divided by the number of customers at the active inbound node. So, the conversion rate for each node is the customer count at that node divided by the customer count for the active inbound node. We can continue breaking this down step by step. The aggregation for each node's customer count is based on the sum of customer counts, and the dimension is the stage, or node. But we also have a special condition. We only care about the active inbound node. We don't care about the other nodes. Let's go into the project and write the function. For the first part, we'll calculate the customer count for each node. This is done by using define function, summing the customer counts and grouping by the node dimension. The result should be the same as if we just dragged the customer count field into the table. Let's verify that. As we can see, the results are the same, which means our function is correct. For the second part, we need to calculate the conversion rate, which requires adding the filter condition to focus on the active inbound node. Some of you might instinctively add a formula like this and then check the results. But here's a problem. Although the customer count for the active inbound node is correct, the results for the other nodes are all blank. Why does this happen? The issue is that when we add a filter condition for the active inbound node, it conflicts with the other nodes. For example, if we're calculating the customer count for the quotation node, we expect to sum the customer counts for that node. However, with the condition applied, it will only include data where the node is active inbound, and there will be no customers in the quotation node who also meet that condition, so the result is empty. The solution is simple. Instead of aggregating by the active inbound node, we aggregate across all nodes and then apply the filter for active inbound. This way, we get the correct total customer count. Let's try it. First, we remove the node dimension and aggregate the customer count across all nodes. This should give us the total customer count. We can see the result is about 100,000, which is the total number of customers across all nodes. Now, we add the filter condition for the active inbound node. And the result is correct. Only the data for that node is included in the sum. Finally, we calculate the conversion rate by dividing the customer count for the first node by the total customer count and format the result as a percentage. This gives us the conversion rate for each node based on the active inbound node. In the third session, we'll take this a step further and calculate the conversion rate for each node based on the previous node.